Hi, everyone. Welcome to the Art of the Possible series. I'm Nihali Niyogi, and I'm a Principal Cloud Solution Architect at Microsoft. If you've been following along with me, this video is part of a playlist on third-party partner solutions in vWAN, and today's topic more specifically is on Cisco Meraki. With me, I have Cynthia Treger, who is a global black belt at Microsoft focused on Azure networking, and she is my accomplice on this ISV series. And Cynthia, really appreciate your efforts from idea to execution on this. We also have a strong team of Q&A panelists focused on Azure networking to support this initiative. And with that, I'd like to introduce our special guest for today, Juan Sturbank, who is a solution engineer from Cisco Systems. And before I hand it over to Juan, Cynthia, would you like to add anything specifically for today's use case?
Yes, thank you, Neali. Sure. So yeah, hello everyone. Hello Juan, hello Neali, and also team. Today with Meraki, we're in a situation that is a bit different than with the previous partners we've hosted so far. In the way that for Cisco Meraki SD-WAN solution, we don't have a managed offer inside the virtual hub, meaning we don't have any managed NVA. We can deploy alongside express route or VPN gateways inside the virtual hub. But as we've seen in the previous sessions, we do have the BGP endpoint capabilities that allows a direct peering between the virtual hub and NVAs that would be hosted inside the spoke of that vHub. And this is what we will deep dive today with Juan for the Cisco SD-WAN for the Cisco Meraki SD-WAN solution.
Thanks, Cynthia. Great call out. Yes, be sure to check out the kickoff session as well for some more details on that scenario. So with that, Juan, really appreciate you joining us today and sharing insights on and perspective on Cisco Meraki product. So over to you.
Beautiful. Okay. Thank you so much for the introduction. Today, I'm going to be talking about Cisco Meraki. What is it that we do, how we build SD-WAN fabrics, and particularly how we integrate with Microsoft Azure, especially with the vWAN service, right? So let's get this started. So basically the flow that we are going to go through today, we're going to be talking about like Cisco Meraki as a solution. What is it that we offer? The way that we build SD-WAN fabrics, the options that we have to integrate with the public clouds out there, and then of course focusing specifically on how we work with Microsoft Azure, both from an integration perspective with vWAN, the automation options that we can leverage, and what's next for our offering in the public cloud world. Right? So those are going to be the main topics. So yeah, let's start with Cisco Meraki. What is it that we do? What role we play within the major Cisco Systems company, right? So Cisco Meraki, because maybe some of you, this may be the first time that you heard the term Meraki or Cisco Meraki, right? Meraki was actually a startup company that was founded in 2006 and was later acquired by Cisco in 2012. The main intention of Meraki back then was basically to deliver wireless networks managed through a cloud portal, right? So basically these guys, 3 MIT graduates, designed like this cloud management system for wireless infrastructure. And basically that idea caught up pretty quickly compared to other solutions that we had back then. It was pretty innovative. And and 6 years after that, it was acquired by Cisco Systems. Since then, we have added more and more solutions into this cloud managed architecture powered by Cisco Meraki. And I have some numbers that will show you the impact that this particular solution had on our client base. Now, as a platform, the main intention behind Cisco Meraki solutions is basically to deliver a cloud managed experience in the same fashion as you leverage the Azure portal right now. You basically go to portal.azure.com to do whatever you need to do with Azure and deliver through cloud SaaS experience. The same happens with Cisco Meraki. You basically go to dashboard.meraki.com, and through that you do whatever you need to do with your networking solutions. Remember what I said? It started off as a wireless management tool, but right now, take a look at what we can do. It's basically pretty much the entire enterprise networking full stack. We can have conversations on wireless switching, mobile device management, SD-WAN, which is going to be the focus for us today, and quite a few more things, right? One thing that I want to call out, in a similar fashion as it happens with Azure, there are multiple ways to interact with that solution via APIs, PowerShell, CLI, the portal. With Meraki, you have basically the cloud, and of course the APIs. Whenever you're talking about APIs, there's multiple ways to leverage those: Python, Ansible, Terraform. There's quite a few things, and I do have some slides that cover that, specifically with focus on Azure integrations. But yeah, it's a pretty complete solution. Something that's happening at this point in time is that we're basically onboarding plenty of classic Cisco solutions in the Catalyst product line into the Meraki cloud. So basically, this is getting more and more powerful by the day. One thing that I want to make clear in here, because again, maybe some of you are familiar with certain solutions that Cisco has to offer, particularly when it comes to SD-WAN and integrating with the public cloud. Cisco has two major solutions: Cisco Meraki, the one that we're going to be talking about today, and Cisco Catalyst SD-WAN. That's going to be presented in a different session. That's usually positioned for situations where you need a little bit more configuration optionality and granularity, right? So that said, again, Cisco Meraki was originally a startup that maybe sold that solution to a few customers out there. After it was acquired by Cisco, and we started adding more and more power to this solution. This is the impact that we have as of 2024. And I can show you this next once we go through the Meraki cloud. We are basically managing through our cloud more than 5 million customer sites or networks, as we call it. There's more than 14 million Meraki devices. Within those devices, I'm including everything: switches, access points, MXs, virtual MXs in Azure, for example. Everything is in that. So it is a pretty scalable solution. We have a 499 cloud SLAs, data centers all over the world that power the Meraki portal. So it is truly a really powerful solution with plenty of scalability, all the while maintaining simplicity, which is basically the main intention of this cloud managed solution, right? Now, one thing that may not be clear to you, because so far we only took a look at the slides, whenever I say the Meraki cloud, this cloud managed enterprise networking solution, what is it that I'm talking about exactly? So let me show you here on my browser what the Meraki cloud actually is. Basically, whenever you want to manage any Meraki solution, right, any Meraki hardware, you go to dashboard.meraki.com. Get in there, provide your identity. As long as you already pre-created a tenant / organization, as we call it, you will be able to get in. Remember that number that I told you, the 5 million sites that are being managed by Cisco Meraki Cloud. This is an actual graphical depiction of that statement. This is real time. Since we have visibility through the cloud, we can actually give you an accurate number on what our impact is. And if this is the first time that you're looking at Cisco Meraki, rest assured, should you decide to deploy this in production, you're not going to be a beta tester or a guinea pig. This is something that has a really strong impact worldwide. So that said, let me give you an example of an actual production network and what the Meraki Cloud can deliver, right? What you're looking at right now is basically the organization / tenant that interconnect all the Meraki offices worldwide. We have quite a few offices all over the world, in the United States, of course, Europe, Australia, Asia Pacific, and all that. Particularly right now, we are looking at the Chicago office, and inside of this particular site, we have pretty much the Meraki full stack, switches, access points, and all that. Again, today's focus is going to be on the SD-WAN and security solution with the MXs and virtual MX. But again, whenever I say the Meraki Cloud, this is actually what I'm talking about. This is the portal, the SaaS website that we use to troubleshoot and manage networks, right? So back to the slide. Let's cover now Cisco Meraki SD-WAN, which is one of the solutions that we can manage through this cloud, right? So Meraki SD-WAN is basically powered by these devices that you are looking at right now on the screen, right? This is called basically the MX product line, right? Meraki MXs. There's quite a wide variety of these products, starting from the MX67, that's usually positioned for small physical branches, all the way up to the MX450. We actually have a new model that is going to come out next calendar year, the MX650, that can scale beyond these numbers for like truly high-end deployments. But yeah, all of these physical MXs are going to be positioned for your actual SD-WAN fabric in your physical sites, right? Which one will you go with? That depends on the scalability that you're looking for. Here you have an idea on what the performance is going to look like for different situations. I would recommend, though, taking a look at the sizing guide over here. That specifies the performance, the document specifies the performance under different conditions. It gives you more idea on the number of flows / sessions that the firewalls can support. And the good thing about this document is that those numbers were actually derived from testing, right? The same can be said for the virtual MX, which is going to be kind of the primary focus of today's session, right? The virtual MX is a virtual instance of the MXs that actually allows us to connect to public cloud deployments, Azure being part of that. As you see right here, there's different variants of the virtual MX depending on the scalability that you seek. In the sizing guide, as you see down here, we basically provide more numbers to make sure that you actually pick the right image for your deployment. These cellular gateways over here, those are going to be of interest to you in case you want to have a cellular backup managed by the Meraki Cloud. That's only relevant for the physical deployments. The virtual MXs, of course, that's going to be in Azure. There's no concept of a 5G interface, right? But yeah, Cisco Meraki SD-WAN is actually delivered by these solutions that you see right here. Now, when we say SD-WAN, right, in and out of itself, SD-WAN, it's an agnostic term. There are multiple features that you need to enable in order to make this happen, right? Every single solution out there basically involves different configuration steps for you to actually implement like a proper SD-WAN fabric. For Meraki, what this actually means. So whenever we say Meraki SD-WAN, what we actually got to do in the cloud to build the SD-WAN fabric. And that is basically takes like 3 different configuration steps, right? Which is setting up the SD-WAN fabric, then setting up the routing rules, like which tunnel or internet interface a packet should go through, and then monitoring the whole thing. As you can see right here with Meraki, all of that is powered by the cloud. So how we actually manage to accomplish the first step, setting up the SD-WAN fabric. And this is a pretty simple process with Meraki. It's literally, as you see right here, it takes 3 clicks for you to enable the SD-WAN fabric between the physical sites and the public cloud. In this case, of course, it's going to be Azure with the virtual MX. So you basically go to the Meraki cloud and you say like, hey, I want you to be a hub, I want you to be a spoke. Automatically, the Meraki cloud will figure out what the public IP addresses are going to be, the number of WAN interfaces that you have, and based on your VPN role, it will instruct the MXs to establish these tunnels. You see this name right here, Auto VPN. That is the number of the tunnels inside our SD-WAN fabric. Why Auto VPN? Because it is truly an automatic VPN. I have been 10 years with Cisco, so I've seen quite a lot. Speaking purely out of experience, Auto VPN is one of the most stable and scalable VPN solutions that I've seen, right? So don't take my word for that. If you're interested and you want to see it in action, we do have multiple ways for you to get trial units and see it yourself. But it not only is simple, but it is also a very stable solution. So let me show you actually in the Meraki dashboard how is it that you will set up this Auto VPN fabric. Basically, you would go to any Meraki physical or virtual MX, right? And once you go in here, you will go to site-to-site VPN. This is where you basically enable the Auto VPN fabric formation. If this is a brand new MX or virtual MX, this is going to be off. The only thing that you gotta do really to make this happen is say like, hey, you're going to be a hub, or maybe you're going to be a spoke. If you're a spoke, who are my hubs, right? You can add up to, I believe it was 8 different hubs, right, with different priorities. But really, this is the only thing that you gotta do to establish the VPNs. Forget about having to configure a template with the IPsec policies and all those, crazy settings. We take care of all that for you, right? That's kind of the main intention behind the Meraki cloud. Not only delivering enterprise-grade solutions, but also introduce simplicity through that process. And you can see that right here when setting up the Auto VPN fabric. Now, we're going to talk more about this later. Usually when you deploy particularly a virtual MX in Azure, usually based on what I'm seeing with my clients, that's going to be a hub, right? So it's going to be concentrating Auto VPN tunnels from the physical branches into the public cloud, right? But for the rest, that maybe is going to be spoke, right? So this is what it takes. This is what it takes to set up the Auto VPN fabric. But remember, SD-WAN is more than that, not just setting up the tunnels from here and there, right? The next step is basically to make use of all these tunnels that you have, all these internet connections all over the place, and make sure that always the best path is being used for a certain application or traffic, right? And we can certainly make that happen with Meraki, right? One of the things that you're going to see later is how is it that we can do performance-based routing, right? In order to do that, after we establish this Auto VPN fabric, these tunnels, we will measure the performance of all these tunnels. We use basically UDP probes inside of them. They run every second. And that allows us to estimate packet losses, jitter, latency, pre-calculate the MOS. And we can use that criteria to take routing decisions. Only if you set that up, right? It's not going to be there by default, but that automatically we will measure the performance of these tunnels, right? So being a little bit more specific, when I say SD-WAN policies, what are the options that you have with Meraki? And again, here in this slide, you can see pretty much everything that we can do. There are options for the standard primary and secondary interfaces, active-active load balancing. Certain physical models have the option of adding a tertiary WAN connection for backup purposes, right? And also, depending on where the traffic is directed inside the VPN, or straight out to the internet. Usually, when the virtual MX and Azure are involved, we're going to be talking about this category right here, traffic inside VPNs. But either way, we can do both policy-based routing and performance-based routing, right? Policy-based routing means I match a certain packet or application, and then I statically say like, hey, you will use this tunnel or interface as the outgoing path, right? It's pretty much like a static set. Performance-based routing is a little bit more complex in the sense that let me measure every single possible option that I have to get to Azure, for example, and I am going to pick the best one for this particular application or flow, right? So we can very much do that with Meraki, as you see right here. Let me show you actually how you would set that up, right? So let us assume that this is a Meraki MX that's a spoke that is connecting to a hub, a virtual MX in Azure. So if you want to do these SD-WAN policies, right, you will go to this option right here, SD-WAN and traffic shake. Inside this page, you have all the options to do this, policy-based and performance-based routing, right? There are some general rules for you to do primary and secondary uplinks, like who's going to be my active uplink, whether or not you want to do active load balancing. Again, these rules will come into effect if there's nothing more specific matching a certain flow, right? Now, this is where the actual action happens, like the actual SD-WAN policies. Here is where you can get crazy with all the performance-based routing, policy-based routing, and all that. As I show you guys in the slides, there are categories for internet-bound traffic and VPN traffic, right? But let me just give you an example, right? Let's say that we have some traffic going inside a tunnel to Azure, right? The way that you can set up a performance-based routing policy for traffic inside the VPN is going to be through this. You do have the option to match, layer 3 and layer 4 information. Normally, I've seen people actually using, MBAR services, network-based application recognition, to match the application directly. Like, for example, Microsoft Dynamics 365, right? You can match as many applications as you like through this classification policy. And then you see right here, once we identify the traffic, what are we going to do with this? You can do a standard default performance-based rule that says pick the best that is the best tunnel that is suited for voice or IP. But check this out. What you can do also is say like, hey, by default, I'm going to use the tunnels out of the WAN circuit, right? And then fail over if there's poor performance. Now, what's the criteria for poor performance? You see down here, you have the option of creating custom classes, right? Those are going to be created over here. You can add multiple performance classes, and every single one of them could be specified to match the performance criteria for certain applications. So we were talking about Microsoft 365, right? So maybe for Microsoft 365, we're going to be talking about like maybe, I don't know, 30 seconds of latency. That's going to be like, the maximum acceptable, 15 of jitter, and 3% packet loss, right? You can define multiple performance classes and use every single one of those to take routing decisions under our SD-WAN fabric. Mihaly, I see you have a question.
Yes, sorry, Juan. Yeah, you can finish this thought. It was from the previous slide. So I'll let you finish this thought and we can go back to the slide.
Yeah, absolutely. There's really just one more thing that I wanted to show you in here. So far, we took a look at how to establish the VPN connections, the VPN fabric, how to do routing inside the SD-WAN fabric. The last portion is basically how to monitor, how to see this in action. And for that, we use this tool right here, the VPN status. This will show you all the tunnels being established in this particular organization, right? You can see some of that through this pie chart. So this is our site that we're looking at right now, the Chicago Old Post Office. And we are particularly establishing tunnels to these two other sites. If you actually want to see the performance of individual tunnels, you can click on this option right here, a certain flow to a certain peer. Since Meraki Chicago and San Francisco have dual interfaces each. That means there are a total of 4 different tunnels between the two MXs, and here we can tell you the performance of every single connection, right? If you had performance-based routing rules, we use basically this data to take routing decisions, right? So yeah, that's basically at a high level what Meraki can do from an SD-WAN perspective, and all of these services that I show you in here are very much available on the virtual MX option that you can deploy in Azure. That's going to be the topic that we'll cover next. Let's go back to the slides and address the questions that Nehali had.
Yes, thanks, Juan. So on the previous slide where you had the SD-WAN fabric and the hub and the spoke design, or the hubs defined, yeah, this one. So
Yes.
I just want to think through this. So here, all the green MXs that you have displayed are, of course, the physical one existing, and we drop one in Azure, let's say. How does one decide in this topology which one is the hub and the spoke here? I was just trying to think through from an architecture perspective. What would Azure be, the VMX in Azure be?
By and large, all the engagements that I had with my clients, whenever the public cloud is involved, and by the way, I cannot share the numbers, but by a long shot, most of my clients go to Microsoft Azure whenever the public cloud is involved. All of the time, the virtual MX in Azure behaves as a hub. The reason being is that in Microsoft Azure, people deploy centralized applications or services that every single branch out there needs to contact. Because of that, it makes sense for the virtual MX to be a hub. If an MX or virtual MX is not a hub, basically the only other option is for that to be a spoke, which means if you're running centralized services in Azure in this case, assuming that this is a spoke, whenever someone needs to contact anything behind the virtual MX, that would mean like, hey, the spoke has to go to hub, and then from the hub down to the tunnels again to the virtual MX and to the underlying Azure infrastructure as a service resource, right? It is certainly possible, technically doable. If you're basically introducing an extra hub that, to be honest, is not necessary. I wouldn't call that an elegant design. And in practice, that's what people do. Usually, the virtual MXs in the Azure public cloud behave as a hub. Also, yeah, one thing that I would like to add to that, and you know this more than I do, right? The public cloud gets involved to replace on-prem headquarters or data center services, which used to be main hubs, right? So you basically export those sort of networking configurations to the public cloud, right?
Right. So in this case, like the DC and HQ that you have in the bottom right-hand corner could be your hub in the starting such scenario. And then as you bring stuff to cloud, that becomes eventually the hub. But you could have 2 hubs in an SD-WAN fabric, right?
You can have two hubs. You can have up to, so every spoke can actually point to 8 different hubs. I've never seen a customer doing that, to be honest, but I mean, the solution is perfectly capable of delivering that scenario, right? You can actually do more if you start doing like tenant segregations. The thing is that's only like for really, really large scale operations.
Okay. And I had one more question, more like on the terminology and my understanding. So when we say SD-WAN fabric and then we use the term auto VPN, does under the hood it still use like the classic IPsec protocols like UDP 4500 and 500, or are the different ports being used?
That's actually a really good question. AutoVPN, to answer that specifically, it's a proprietary, Cisco proprietary VPN solution. It's heavily based on IPsec, right? The thing is, it uses different ports. An AutoVPN tunnel, at the end of the day, is basically a UDP encapsulation. The ports that we use are dynamic, basically orchestrated by the Meraki cloud. So usually what happens is, let's say that we bring up the virtual MX in Azure, right? Comes up, it is provided with a public IP address. We're going to touch more on that once we go over the virtual MX as a managed application. But basically, somehow this guy contacts the internet, and by doing so, it will contact the Meraki cloud. When the Meraki cloud receives the connection from the virtual MX, it says like, oh, you're this virtual MX, you're supposed to be a hub, a spoke, what have you, you're in this Meraki tenant. What is your public IP address? This one? All right, cool. It gets that information. It does the same pretty much for all these other physical MXs or virtual MXs. You could have multiple virtual MXs in different, Azure tenants, for example, or multi-cloud deployment. That's also a possibility. But we fetch all of that information. We know where everyone is at, the way that they have to contact the internet, and based on it, under our VPN role, the cloud, the Meraki cloud, instructs all these MXs to say like, hey, you have to establish all these tunnels to, the hub, to other spokes, whatever that may be, and these are going to be the ports that you will use, right? Those are going to be dynamic ports. Now, you do have the ability to set that statically, because sometimes, and this is actually that I will show you later, the virtual MX in Azure is deployed behind other firewalling NVAs/appliances. And because of the operation of these NVAs, you may need to do a port forward rule. To do that well with Meraki, you need to set up that UDP port statically. That's an option that you can do with us. But by default, AutoVPN will just figure out these ports dynamic.
I see. And is that range of port published, or is it I know you said dynamic, but is there a range that's published and well known?
Yeah. So all the requirements for Meraki to work as a solution are going. You can find that in the documentation, right?
Okay.
But in case you want to take a look at what actual connectivity requirements you will need for your particular deployment, you will go here to your Meraki dashboard, click on the question mark icon, click on firewall information, right? Because again, you may have a firewall up front that may be blocking some of this, and here we will tell you like what is it that you need for every single service, right? So,
got it. Yep. Thank you.
perfect. Any more questions?
Maybe Juan. Sorry. Was it Cynthia?
No, it was me, Nehali.
Yeah.
But go ahead.
Okay. Yeah. So maybe you'll cover this later, Juan. But the VMX that you showed us in Azure, is that like an active or active standby, or are you going to go into the details? I can wait. Just curious about the mode.
So once we go over the virtual WAN integration options,
yes,
I will talk about like the high availability deployments that we have. But that, to answer your question right now, it's basically active standby. Active if you want to do that properly through a cluster. Cisco can only technically do that with the secure firewall option / firepower virtual. By leveraging the application gateway load balancer, right? To actually do like a VXLAN communication between the two, right? But at the end of the day, like even though like both virtual MXs or 3 or 4, whatever you want to add into the so-called cluster, all of them are going to be operating, but they do not form like a cluster between themselves. It's basically how you do dynamic routing and prioritization of the cache. But yeah, we will cover more of that in the next sections.
Okay, great. Thanks.
And I was just going to ask if the BGP peering is going to be discussed, particularly for multipathing later on too.
Yeah, so I will show you the stuff that we can do with BGP natively on the Meraki MXs.
Okay, great. I'll wait then. Thanks.
Perfect. All right, so we talked about this. It's good. Another thing that I wanted to touch on for the Meraki MXs is that this solution is not simply an SD-WAN solution, right? It can also do advanced security, and as it's typical with Meraki, that is delivered to you in a simplified way, right? So all of the services that you see to my left, stateful firewalling, IDS, IPS with Cisco Snort, malware protection, and URL filtering, those two, well, actually these three right here, powered by Cisco Talos. All of these services can run natively on the Meraki MXs, and as of recently, talking about a few days ago, the virtual MXs can also now support these security operations, right? Now, let me be clear, it is totally optional. It's not that the moment that you deploy a Meraki MX or virtual MX, that these services are going to be enabled. You got to go and do the configurations for this to be turned on, but it is very much an option, right? Usually, the physical SD-WAN deployments will run these security services because you need to secure your SD-WAN fabric, right? It's not just like a VPN implementation, right? And adding an extra solution on top of the SD-WAN boxes, though possible, is not cost efficient, right? So it makes sense to run all of these services in the same box, right? And Meraki can certainly get you there. And as of recently, the virtual MXs too, which opens up different use cases for us in the public cloud. So more on that later, right? Now, these advanced security services, we do extensive testing to make sure that they are actually efficient. The results that you see right here were published by Mircom, and we are pretty much 98% effective based on all the testing that these guys did, which is basically 25% better than the average out there in the industry. And the reason why this is because Meraki is not like an isolated organization within Cisco. We do leverage plenty of Cisco technologies natively in our boxes, again, delivered to you in a simplified way. That's like Meraki's motto. But the reason why we got such high scores is because a lot of these security services are powered by Cisco Talos. In case you don't know what Talos is, it's basically, this is a security group within the company, which its sole purpose is to constantly analyze global threats, new malware that's being detected, malicious flows that are cataloged as suspicious. And we do a lot of automation behind this data, a lot of AI analysis, plus, as you see right here, we have quite a few security experts, 500 of them, to make sure that any Cisco security solution, Meraki, FirePowers/Secure Firewall, the security services that we will introduce in the Catalyst 8000 routers, Secure Client, if you want to do a native client level security, all of the DNS security that we can leverage through Cisco umbrella, everything that has security within the Cisco portfolio, again, Meraki included, is powered by this Talos group. And this is one of the primary reasons why we are so effective. As you see right here, we block 20 billion threats daily, which is 20x over most popular vendors out there. So again, as I was saying, this is one of the reasons why the security implementation on Meraki and any Cisco product for that matter is so effective, right? Whenever something new is detected, we automatically update the Cisco security solutions out there to make sure that they contemplate that rule, right? Now, going back to the dashboard, right? If you want to turn these security features on, which again is totally up to you, right? And then we're going to touch more on this later once we go over through the designs, particularly for hubs. You may not have, and our recommendation is basically to have two different boxes or virtual appliances to do VPN concentration / SD-WAN and another one for security. You can do both at the same time in a hub if you want to. That's totally doable. Thing is, you gotta consider that the performance will decrease because the firewall is going to be busy doing both security plus SD-WAN / VPN, right? But for a branch, that's not usually an issue. For a hub, yeah, you may want to have like two different appliances. But anyways, where do you actually configure these security services? Again, standard stateful firewalling is going to be here, layer 3 ACLs, layer 7 ACLs, blocking traffic from certain countries, right? All of this is going to be in this area. You see right here, blocking countries, applications, or the layer 3 ACLs, standard stuff. Port forwarding one-to-one NATs if you're hosting any public applications, right? That's could be an option for you. But all of the more advanced operations from a security perspective, especially when the Talos group is concerned, that's going to be under threat protection and category filtering, right? So in threat protection, this is where you turn on AMP, threat grid or sandboxing integration, IDS, IPS with Cisco Snort. And as you can see right here, this is delivered to you in a typical Meraki fashion. There's not a lot of configurations options for you to do because it's just basically like, hey, I want to run IDS, IPS. This is the rule set that I want to implement. You save the configuration and that is it. Automatically, we will get the latest rule set from Talos and start performing IDS, IPS for you. And the same happens for the rest of the security services, right? So yeah, again, optional, but these devices are very much capable of delivering these security features, right? Any questions on this before? No, sorry, not that one. Any questions before we go back to the slides?
Yeah, so quick question, Juan. So this security feature that you mentioned, is that something that you can turn on the VMX and then do both east-west and north-south today, or?
That's actually a very good point. And we introduced the security capabilities in our latest code, 19.1.5. Before that, the virtual MXs were basically an SD-WAN concentration point into the public cloud. They were not capable of behaving as an edge firewall, so to speak. They now can. Now, because of the way that is deployed, and I'm going to touch more on this once we go over the managed application, they are at this point in time suited only to north-south inspection. East-west, yeah, they are not going to be able to do that. If that's what you need, we may need to take a different Cisco solutions in the public cloud, either the Catalyst 8000 virtual, or well, if you need like a full-blown firewalling option, that's going to be the secure firewall / firepower. Okay?
Got it.
Yeah,
Thanks.
If you need east-west, yeah, this is not going to be applicable to you, only for north-south.
Actually, I'll ask another question as well. So the feature that you mentioned, the security feature, is that also available on your MXs, or is that just a VMX specific?
No. This is pretty much every single MX, right?
Okay.
The only thing that you need to consider in here, there are 3 different licenses for the Meraki MXs, right? Which are basically set at the organization / tenant level. So let me show you. If you go here to organization, license information. For the record, the SD-WAN feature set, like the standard SD-WAN implementation that is offered in all the Meraki MX licenses, Enterprise Advanced Security and or SD-WAN Plus. If you want to run advanced security operations, IDS, IPS, advanced malware protection, threat grid integration, ability to link with the umbrella DNS security, all of that starts at the advanced security or SD-WAN Plus level, right? 3 different tiers depending on the features that you need. As long as you have that, every single MX in your Meraki organization will be able to deliver those security features for you. Okay.
Got it. Thanks.
Yep. And again, maybe the last slide will cover this. As of recently, in the latest code that we published, the virtual MX can now run these services if you need to. All right, so let's go back to the slides. Just a quick rundown through the numbers. This is all good, but I always like to show the actual impact that we have in the world. As you can see right here, there's a little bit more than 1.7 million of active MX units out there, including the virtual MXs. And of all that entire deployment, 35,000 clients are running SD-WAN features. If you put that into number of MXs terms, that's going to be more than 136,000. And here you have examples of customers, large customers using the Meraki MXs. Within a single tenant, you're talking about more than 18,000 split across multiple organizations / tenants. You're talking about 60,000. So yeah, it is a pretty good scalable solution, right? So with that said, let's talk about the virtual MX, because this is going to be basically our entry point into the Azure public cloud, right? So as we were discussing before, originally when we introduced the virtual MX into the market, it was basically, as you see right here, an AutoVPN / SD-WAN termination point, right? It was not able to operate as a firewall. That changed after 19.1.5, our latest firmware. It can now behave as a firewall if you need it in the public cloud, right? Now, from a VPN concentration perspective, of course, besides concentrating Meraki SD-WAN or VPN tunnels, you can also do client VPN concentration, right? Let's say that you have remote workers that for whatever reason need to establish a client VPN connection into Azure via the virtual MXs. You can certainly do that with AnyConnect / secure client, which is the new name for AnyConnect, right? Again, originally it was deployed with a single interface when it was a one-arm concentrator, but now in firewall mode, it basically has 2 interfaces, outside and inside, right? And it comes in 4 different sizes, depending on the performance that you need. Remember to check the sizing guide if you need more details on the number of flows, number of recommended clients and all that. But from a throughput perspective, this is going to be kind of like the differences between all these sizes. Now, one thing that I want to call out, the extra large version, as of now, it's only available in AWS. It will be introduced in Azure early next calendar year, right? That's going to be for a larger use cases. So that's kind of a high-level overview from a supported platform perspective. We can run on all the major public cloud providers. And also under the Cisco and FBIS virtualization engine for private deployments. Just so you know, we do have it in our roadmap to introduce an OVA version if you need like a VMware support in ESXi or maybe KVM. That's going to come later. But one thing that I want to call out in here, talking about like the internal numbers that we have that I can share here, and also my experience. By and large, by a long shot, Azure is the most popular public cloud provider based on the virtual next implementations that we see, right? So yeah, I just want to mention that. Now, as I was saying before, when you do deploy the virtual next, usually you do so to extend the SD-WAN fabric, which is going to be these green tunnels you see right here, into Azure. And once you have that private connectivity, besides like taking SD-WAN routing decisions, you can now access contact privately or all of your Azure resources, right? That's by far the most common use case. And again, as of recently, we can now do firewalling. Now, I will show you this shortly in the Azure portal, what this looks like. But once you, how is it that you actually deploy a Cisco Meraki virtual next? It's basically something that is found under the marketplace, like any external NBA. And once you deploy this, it's basically done inside us under the managed application and construct. This managed application pre-creates resources once you deploy the virtual MX. Specifically for the VMX, this is going to be the things that are going to be inside the managed application. It's going to be a managed resource group, virtual machine with, well, in this case, you see a single NIC, but now we have the ability of doing dual NICs with the firewall mode, if you choose that. This one of the NICs is going to have a public IP address for internet connectivity. You may or may not leverage that public IP address depending on how you do the default routing inside Azure. Maybe you have a route table with a new DR to maybe route it through a firewall, what have you. That's certainly an option, but yeah, by default the managed application has this public IP, and then of course the virtual machine and its resources to run the virtual MX image, right? That's at the end of the day what this managed application has. If I were to show you here, give me 1 second, in the Azure portal, where you can find the Meraki VMX, you could basically go to the marketplace, search for Meraki VMX, and there you go. This is going to be the place where you would create the managed application, right? So you would click on it and then basically provide all of this data. One thing that I want to call out, you see here the Meraki authentication token. This is something that you generate from the Meraki dashboard when you add a network with a virtual MX on it, like an empty virtual MX. That authentication token is basically what links this virtual machine under the managed application to the Meraki dashboard, right? So this is what the process looks like. Yeah, going back to the slides. There we go. Let's talk about now like the options that we have to integrate with Azure, right? And for this, I am going to open up my Draw.io document. I have multiple use cases in here on how is it that we usually deploy the virtual MX, like the options that we have to deploy it inside of Azure, right? So as you can see right here, this is going to be for like smaller deployments, people that need maybe a single instance, right? And just to connect the SD-WAN physical fabric to the virtual MX, right, in Azure. This is the recommendation both from Microsoft and Cisco to basically leverage a hub and spoke VNet topology for scalability. Ideally, you would deploy the virtual MX as an MBA in the hub VNet. This is going to be where you would terminate the auto VPN tunnels. It is also an option for you to remember to do client VPN via the Cisco Secure Client if you so choose, right? But normally we see auto VPN being leveraged. And remember this, usually the virtual MXs or hubs are auto VPN hubs, which means we would recommend having a virtual MX to concentrate the auto VPN tunnels and a different one in the hub VNet in case you want to take advantage of the firewalling capabilities. Now, as you see right here, the virtual MX is not the only option to do security with Cisco in Azure. You also have the secure firewall virtual / firepower, or the Catalyst 8000 virtual. And of course, the Azure firewall can very much working here. So it's totally up to you what you choose to do security. But yeah, virtual MX is certainly needed to do the SD-WAN fabric integration, right? Now,
Juan, I have a quick question on that. So you would recommend separating the concentrator mode from the firewall mode on 2 separate devices, right?
yes.
Yeah.
Generally, that is our recommendation. And you, potentially, you can terminate everything here in the firewall virtual MX, right? So this guy could do both security and SD-WAN. Thing is, the performance is not going to be excellent, particularly if you have a lot of VPN tunnels terminating in Azure, right? Which is usually the case because these are hubs, right? So yeah, generally speaking, this is what people will choose to deploy.
Okay.
Yeah.
And sorry, so it's actually the same image that will provide SD-WAN and firewall capabilities, but then you decide to activate one or the other on the image, or is it like separate images?
No. It's
same
pretty
image,
much
okay.
the same image. And actually, I will show you where you can change the operational mode. So if you go here to security and SD-WAN, addressing and VLANs, under this you say like, hey, are you a routed appliance, which means firewall, or pass-through or VPN concentrator? So you hit on save, and that is it, right? If you are doing pass-through, this option is not going to be available to you, right? Like the security features, because it's just concentrating tunnels. But yeah, that's all it takes. Same image, same managed application, same everything. Yeah.
And the recommendation to not combine security and connectivity on virtual appliances also, is it the same for physical appliances, or is it only for the cloud?
It is also a recommendation for physical appliances if they are in a VPN, in a hub, right? In a main site that's concentrating tunnels from everyone else. For the spokes, which honestly are doing tunnels to hubs, it's only like a small amount.
Yeah.
Do run both security plus VPN, right? Otherwise, you're going to be unnecessarily spending money.
Okay.
Again, for Azure, usually we're talking about hubs, so this is going to be the recommendation. Now, this is like the single instance deployment, so nothing overly complicated. What happens when, whenever we need to connect multiple regions or, add high availability into the mix, right? So let us discuss first the high availability option, and then of course we got to touch on virtual WAN, right, for the multi-region deployment, right? So whenever it comes to high availability, or let's say horizontal scaling, in case a single virtual MX is not enough for you, right? Basically, what we need to leverage in here is a design similar to this. Again, we are going to follow the hub and spoke recommendation from Microsoft when it comes to the VNet peerings, as you see right here. And basically what you do is deploy multiple virtual MXs. In this example, we have 2, but you can't have more, right? Remember, every physical spoke can point up to 8 different hubs. And what you do here is basically in Meraki, you say like, hey, this is my primary hub, this is my secondary hub, this is my tertiary hub, right? All of these guys could be here in Microsoft Azure. And then you peer the virtual MXs via eBGP to, for example, a route server, right? When you do that, of course, one of these virtual MXs is going to be the one in charge for certain spokes. If this one fails, the beauty of dynamic routing and the route server in Azure is that, let's say that the red virtual MX in availability zone number 1 fails, automatically the BGP is going to purge those routes. The route server in turn will instruct all of the Azure infrastructure to remove those routes and automatically point that traffic to the other virtual MX, right? So this would be our recommendation whenever you need to introduce high availability. and have a dynamic failover, right? So yeah, that's basically the way it works. And also the beauty of this design is that the virtual MXs being hubs and the physical sites usually being spokes, based on the hub priority that you defined on the Meraki side, right? We will automatically perform BGP AS path prepend. So the physical subnets, the physical routes living in the on-prem world, when advertised from the virtual MXs into Azure, in this case the route server, but it's also applicable to the V1 hub, for example, we will do AS path prepend for you. So if, let's say, the green virtual MX in availability zone 2 is the secondary hub, the routes from this virtual MX will be less preferred by Azure. So when these two are active, Azure by default will prefer the Meraki primary hub, right? In case this one fails, of course, we will route over the traffic to the other one, right? So yeah, the only thing that you gotta do is deploy the route server, establish the eBGP connections, and that is it really. Everything else is taken care of by Microsoft and Meraki, right? Now, this leads us to the next design, which is going to be leveraging the virtual WAN option. And usually, based on my experience, this is something that we see our customers deploying whenever there are multiple regions being involved. The beauty of virtual WAN is that it behaves as a main routing fabric for all of your Azure regions under your public cloud deployment, right? So if you have Meraki SD-WAN running in this global or multi-region deployment, we can certainly leverage Microsoft vWAN to do the dynamic routing to it. Now, as Cynthia was saying, we do not support a native integration into the V1 hub itself, like we do with the Catalyst 8000, for example, right? So in order to make this work, basically, for every virtual WAN hub that you have, you basically need to deploy a VNet with the virtual MXs inside of them. In this case, you see a couple in case you want to have like local high availability via availability zones. You can deploy a single one if you want. Usually, I mean, our recommendation is to have more just in case something fails. That's up to clients whenever they deploy this solution. And so yeah, you basically deploy the virtual MXs in a VNet, and then perform the virtual network connections to the V1 hub. And once you do that, you basically have the ability to do eBGP peering towards the V1 hub in the same fashion as what we can do with the route server. Now, the beauty of virtual WAN, as you probably know, is that the scalability is going to be significantly higher when compared to the route server. So yeah, that's going to be pretty much the way that we have to integrate with virtual WAN, right?
And so it will be one eBGP session towards each VMX instance, right?
Correct. I believe like 2 eBGP sessions are required for the route server and the V1 hub for high availability. So
yeah,
so 2 per instance basically. Yeah.
Okay. And is it possible to horizontally scale that deployment and have more than 2 MX in an SD-WAN hub?
That's actually a good question. It is very much a possibility. The thing is, the way that horizontal scaling works with Meraki, the virtual MXs cannot run, for example, on the Azure's virtual machine scale sets. So it's not possible for you to dynamically add more CPU and RAM resources into the VM. So what normally people do when they need horizontal scaling, first off, if vertical scaling is not an option, like upgrading from large to extra large or what have you, that you do need to deploy more virtual MXs, what happens is, let's say the red virtual MX behaves as the primary hub for a certain set of spokes. The green virtual MX behaves as the primary hub for a different set of spokes, and each of them are each other's backup in case something fails. You can replicate that configuration by adding more virtual MXs. So every single one of them takes care of a certain set of spokes, but they can back up a different virtual MX in case of failure. You can also do like an active standby if you want, like, hey, this is the primary hub, this is the secondary hub that by default is not going to be handling any traffic at all. And if you need more VPN concentration, you basically copy paste this design, like add an extra couple of virtual MXs and so on and so forth until you reach the capability that you need. And the beauty of all this is because we're going to be leveraging BGP for routing decisions in case something fails, or in the event that we need to send the traffic from Azure to the right virtual MX, we will know how to do that based on the default BGP preferential treatment that we do from Meraki. So yeah, the beauty of all this is that for the most part, the solution takes care of itself on deciding which virtual MX is to be leveraged for routing decisions. So
yeah, okay. It comes with the fact that the tunnels are split across the instances and that the instances back up each other, basically.
that is correct. Yep. Yeah. So yeah, that's going to be the main use case that we have when it comes to integrated with virtual WAN. Again, in this example, you see a couple of V1 hubs, but you can expand this as many times as you need, as many regions as there are in the particular Azure deployment. One thing that I want to call out, it is technically possible now to leverage the virtual MX as a firewall. So we could deploy this as a third-party firewall in the Azure vWAN construct to do some north-south inspections. I didn't add that as a validated design here because being such a new feature, we gotta do some testing before recommending that to customers, particularly for vWAN if you want to do some firewalling protection. But as an SD-WAN/VPN concentration, this is the way that it works. And we do have plenty of clients running this deployment. Yep, Nehali, I see that you have a question here.
Yeah, so I think Javier had a question. He had to drop, but he did mention, so does Meraki support BGP, which I think it does? Any mechanisms to do AS path prepending was his question.
That's actually a really good question. So it used to be the case that the answer would be no. Like we would take care of the BGP AS path prepending based on how is that you set up the SD-WAN fabric, giving the administrator no option whatsoever to manipulate the BGP based on their own preferences. Now, I'm going to skip the automation portion. We can cover this last, just to address your question. Yeah, we already talked about like the new feature, like the advanced security in the virtual MX, but check this. In the latest code, again, 19.1.5 and newer versions, take a look at this. Whenever you set up a new BGP connection, you now have the ability to, on a per-peer basis, to manually manipulate the weight for inbound routes and AS path prepending and MED for outbound routes, right? So the routes that the virtual MXs communicate to the V1 hub or the route server. So yeah, if you are not happy with the default treatment that we will do for these BGP routes, you can do your own path prepending as of the latest code 19.1.5.
And
Awesome.
do you also have ways to match specific traffic?
Oh,
to apply these parameters or
yeah, no, we do not support the route maps or route policies, policies at the moment, so it's going to be pretty much for all the routes.
Okay.
I mean, that's actually a good question, Cynthia. If you need that type of granular treatment, and I know that you can do some of that in V1 now, but yeah, if you need that from the SD-WAN level, you may want to take a look at the Catalyst SD-WAN for those advanced controls, right?
Okay.
So any more questions on the B1 and the BGP?
Not from me. Looks good.
Very well. There's just one more thing that I wanted to touch on, because it's something that comes up pretty frequently, honestly, whenever the public cloud is involved, and you know this better than I do, right? Usually when people get started with the cloud, like they would go through the Azure portal, get used to the public cloud experience, learn the new networking concepts and all that. But once you get pretty familiar, when it comes to replicating a deployment, you don't want to click through the Azure portal hundreds of times, right? That's when automation solutions come into play. Especially for Azure, the ARM templates or Terraform are pretty popular options to automate deployments. And what I would like to mention in here is that you can very much use both to automate the deployments of virtual MXs, and also the same can be said for all the other Cisco virtual services in Azure, Firepowers and Secure Firewalls and Catalyst 8000s. So yeah, you can use either tool, ARM templates, or inside of Terraform, you can use this new resource, Azure ARM resource group template deployment, to basically bake in an ARM template inside Terraform, and it will automatically manage that. And one thing that I want to call out in here, in case you use the prior version on Terraform, it used to be the case that whenever you put in an ARM template inside Terraform, it would deploy it, but it would not destroy it. So there was no like a way for Terraform to keep a state of the the virtual MX managed application. They did change that in this new resource, so you can very much do that if you want to. So yeah, automatic deployments with Meraki virtual MXs being part of that is certainly a possibility. And if you need examples, feel free to reach out. I did deploy this automatically hundreds of times, and yeah, it's impressive how well it works with Azure.
Awesome. Any other gotchas or something you'd like to share, Juan, from what you see in the field that would help make the experience even smoother, or like any other limitations with the number of NICs or anything that you would like to share?
Yeah, that's actually a really good question. I'm going to talk about based on my experience, right? Usually, some of the limitations that we hit is, for the firewalling mode on the virtual MX, we only support 2 interfaces, and the way that we process traffic internally of the virtual MX, we cannot do at the moment east-west inspection. So yeah, that's something that you got to take into consideration. If it's needed, you got to take a different firewalling solution. For VPN concentration, that doesn't really matter because it's basically a one-arm concentrator. So that's going to be one thing. The other thing is that it used to be a problem for us, the fact that we didn't have an option for you to do manual ASPath prepending, right? Because even though like the automatic treatment that I talked about before, that works only for subnets that you get from spokes into the virtual MX hub. What happens if you have another physical hub, for example, doing tunnels to the virtual MX, and you're doing some sort of HA deployment in Azure? We wouldn't do that default ASPath prepending for subnets behind the physical hub. So sometimes we would run into routing asymmetry issues. Now with this manual ASPath prepending, yeah, that's no longer the case. So we managed to solve that. Another thing that I want to call out, you gotta really watch out for the number of routes that the route server and virtual WAN have support, because at this point in time, we do not do a BGP summarization natively on the virtual MX, and natively on any MX, and not just the virtual MX, right? So you, depending on how large your deployment is, you may hit that limit. If that happens, we do have a workaround by introducing a Catalyst 8000 virtual in the middle to do BGP summarization, but yeah, we do have this summarization feature in the roadmap. I just wanted to call that out. Okay, for large deployments, you may hit this limit. And the other thing, maybe you can enlighten me here, because I run this with one of my clients. Whenever you run a virtual machine as an MBA in Azure, it means you're running like a firewalling or SD-WAN service inside one of the Azure's virtual machines. Do we have a limit on the number of flows that we police for that virtual machine? I believe it was 250,000, correct?
Not something I know off the top, but we can find out for you.
Sorry.
Yeah, and this may be outdated information, right? So it's been months since they reached out to me. But if you have like a really large scale deployment, you may hit that flow limit. That based on the information that I had back then, it was something introduced at the virtual machine level in Azure. But this may have been lifted. So, and by the way, it happened to me once, so it's pretty rare.
Yeah, good stuff. So Juan, real quick, there's one question in the chat that I wanted to run it by you, or we could take that offline as well if it takes more time. But so going back to your diagram and kind of
Yes.
Yeah, in this one, so for example, if your, VMX, if you have an express route to your DC or HQ, for example, in the bottom right-hand corner, you have DC and HQ, which is connected to Azure via express route, and you also have the VMX as the hub. Is there any gotchas or any design considerations? And we can take it offline if needed.
It is something that we don't have any public documentation for that setup. I did run into a couple of conversations with my clients, and basically it is something that you can do. You just basically gotta be careful on what the preference is within Azure, right? Like, do we prefer express route, or do we prefer like the routes through the SD-WAN fabric / VPN, right? Normally you're gonna take care of that via BGP. But yeah, we may need to discuss that offline to make sure that we are not
the full scenario. Yeah, that's what I thought. Agree.
But normally people that deploy Meraki SD-WAN will be connecting to the Azure public cloud via VPN / SD-WAN. Express routes, to your point, only come in for like really big sites, like maybe their data centers or headquarters, right? It's not something that they have all across. It's only like at very specific sites, and they send like particular traffic inside express route, not everything. But yeah, we can take a look into that.
Got it. All right, it looks like we're about time. Thank you, Juan. Really appreciate you joining us for the session and sharing all the insights. I learned a lot. And any thoughts, Cynthia, before we close it out?
No, thank you, Juan, for the session. Good recap on the SD-WAN capabilities as well at the beginning of the session. So thank you.
Yeah, absolutely.
Excellent. Thanks everyone for joining, and we will see you in the next video.
Perfect. Thank you so much.
Yeah, I'll stop the recording for now.
Okay.
Yeah, Juan.